At exactly 6:42 a.m. on February 9th, 2026, Ukrainian operators from the 14th Separate Mechanized Brigade launched what should have been a routine surveillance pass over the snow-covered fields surrounding Petropavlivka in the Kupyansk sector. The mission was simple: look, observe, report back. Nobody expected to see anything that would change the outcome of the next 2 hours. Nobody expected to survive the decision they were about to make. The reconnaissance drone fought against ice-cold wind gusts as it stabilized over a stretch of frozen forest. The thermal display flickered, and then it lit up, not like a warning light, like an entire Christmas tree on fire in the middle of hell. What was approaching from the Russian side was not a column of gleaming T-90 tanks. What was rolling toward the Ukrainian front line at that moment was something that made the operators inside a frozen basement 3 kilometers away stop cold. Not from fear, from pure unfiltered disbelief. Leading the advance was an aging MTLB armored tractor, a Soviet-era relic that had probably watched the Berlin Wall come down, now coughing black smoke over pristine white snow, its exhaust trail cutting a dark line through the winter silence. But the MTLB wasn't the punchline. What came behind it was 11 quad bikes, 2 Chinese Desert Cross buggies. Yes, you heard that correctly. Buggies, a formidable assault force. Visually, it looked like a low-budget bachelor party that had taken a catastrophically wrong turn into an active war zone. The Russians, in a stunning display of desperation engineering, had loaded these recreational off-road vehicles with full assault squads. 4 soldiers clinging to a tactical buggy with no doors, no armor plating, in temperatures 10 degrees below zero, rolling directly toward Ukrainian machine gun positions. And as darkly absurd as that sounds, it is not even the strangest form of transport to appear in this war. Because context matters here. Since 2022, Ukrainian and Russian forces alike have thrown everything at the problem of moving troops across a battlefield saturated with drones and artillery. We have seen assault troops on enduro motorcycles threading between shell craters. We have documented soldiers on horseback in rural sectors where thick mud swallows any engine. There are confirmed reports of donkeys being used to ferry ammunition in areas where the roads have simply ceased to exist. Compared to that catalog of improvisation, these Chinese buggies are almost cutting edge. Almost. They are fast, they are maneuverable, and they are completely, spectacularly exposed. A moving target with no protection, carrying human beings who have been told to charge across open ground. A bullet magnet on 4 wheels. Back in that frozen basement, the Ukrainian operators should have been relaxed. They had the enemy in their sights. The numbers were in their favor. This should have been over before breakfast. It wasn't. The laughter in the Ukrainian command post stopped the moment the sensor operator checked the interference readings. The drone was going blind, and the Russians had planned it that way. What you need to understand about the Russian system mounted on that MTLB is that it was not a simple radio jammer. This was not the kind of device you can buy online or improvise in a garage. The system sitting on top of that oxidized chassis was most likely a derivative of the Borisoglepsk 2 or a modified RP 377 field electronic warfare platform. These systems were originally designed to blind the radar arrays of NATO fighter jets and sever satellite communication links. They are strategic-grade weapons being deployed at the platoon level. That tells you everything about how desperate and how creative Russian logistics have become. Here is the precise mechanism that makes the Petropavlivka trap so lethal. The Russian system does not attempt to brute force block your video signal. That would require enormous amounts of power and would be detectable from kilometers away. Instead, it listens, passively, silently, with extraordinary precision. Every time a Ukrainian operator moves a joystick, his controller emits a tiny burst of radio frequency energy, a whisper. The system picks up that whisper. A second antenna array deployed 5 kilometers away on the flank picks up the same whisper from a different angle. Where those two invisible lines intersect on the map, that is where the operator is sitting. That is the geometry of death. The Russian system does not send you a warning. It does not fire a weapon at you directly. It sends coordinates to an artillery battery. And 90 seconds later, a Grad rocket salvo or a laser-guided Krasnopol shell converts your position into a smoking crater. The entire process, from detection to impact, takes less time than it takes to drink a cup of coffee. On top of this, the Russian commander had not chosen February 9th by accident. He waited specifically for the worst snowstorm available. Not to use as cover in the conventional sense, but because dense snow disperses infrared light, degrading thermal camera resolution by 30 to 40%. The MTLB was not just a tank. It was a rolling electronic umbrella, broadcasting interference across a 300-meter radius, while 11 quad bikes carrying nearly 50 assault soldiers fanned out beneath its protection. The Ukrainian operator in the basement watched his monitor dissolve into grey static. Telemetry loss, video signal unstable. The red warning blinked in the corner of the screen. The Russians had done the seemingly impossible. They had used weather and speed to become ghosts. The MTLB was absorbing all electromagnetic tension while the assault force dispersed. And now those 50 soldiers were less than 2 kilometers from the trenches of the 30th Brigade. Artillery could not fire on a target it could not see. FPV drones could not fly blind into that electromagnetic soup. The defenders in the forward trenches did not even know that death was coming at them on small wheels, fast and completely invisible. The team made a calculation under pressure. Standard procedure would be to radio GPS coordinates to the artillery battery, but under this storm, Russian jamming had erased GPS from the map entirely. Transmitting voice coordinates would instantly reveal their position to the MTLB's triangulation system. The clock was running. They had a rule: never transmit from the same position for more than 3 minutes. Above 3 minutes, survival probability dropped below 40%, so they had adapted. They ran Canadian modified firmware that hopped across 114 radio frequency channels per second, transmitting in millisecond bursts just long enough to correct the drone's heading, then complete silence. It was paranoid. It was exhausting. In Ukraine, paranoia keeps you alive. But then, the situation moved from tense to catastrophic. Cold is not just uncomfortable in this war. Cold is a tactical vulnerability. The frequency hopping made the Ukrainian operators hard to hear, but it did nothing about their heat signatures. When the snowstorm broke for a single second, opening a brief window in the clouds, the early warning sensors screamed. A Russian Supercam S-350 reconnaissance drone was orbiting high above the cloud ceiling, scanning the ground with a high-definition thermal camera. The Ukrainian operators' visual camouflage was perfect. Their equipment was not. Starlink antennas warming themselves to melt accumulated snow glowed in the infrared spectrum like lighthouses on a polar sea. Body heat from the pilots seeping through the basement vents was a beacon broadcasting, "I am here, come find me." The team had two options and about 4 seconds to choose. Option A: guide the artillery onto the approaching buggies and accept that a 152mm shell would detonate on their position within 90 seconds. Option B: full blackout, cut power to everything, hide under thermal blankets, hope the Supercam moved on. They chose to live. The monitors went black, the fans stopped. Silence. But silence brought a new terror. The last image on screen before the blackout showed the 11 quad bikes and the buggies accelerating. They were no longer 3 kilometers out. They had crossed the contact line. The Ukrainian infantry in the Petropavlivka trenches was now alone. No ice in the sky, no early warning. Blind in the snow, while 50 Russian assault soldiers bore down on them at 70 kilometers per hour. One operator refused to accept that framing. He looked at the reconnaissance drone's remaining battery, he looked at the distance to the convoy, and he did something that the textbooks do not cover. He pushed the stick forward. The drone dropped from 400 meters into a near vertical dive, entering directly into the small arms kill zone, where Russian AK-12 fire fills the air. As the frozen ground rushed up, the pilot triggered the auxiliary release mechanism. The drone ejected a single chemical exothermic capsule, a modified magnesium thermal flare. It hit the ice-covered road at a natural choke point just before the bridge over the Hanilensia River. On impact, it ignited and began burning at 1,200 degrees Celsius. A thermal beacon so bright it would punch through any camera system in any weather condition. "Package delivered. The door is open," the pilot whispered. The drone pulled out on momentum alone, its wings half frozen, escaping before the Russian gunners on the buggies could lift their frost-covered heads. At 8:35 a.m., the FPV attack team powered up their weapon. The drone was not a commercial racing quad. It was a heavy-frame carbon fiber platform built specifically to carry a TBG-7V thermobaric warhead. 2.2 kilograms of a charge designed not to penetrate steel armor, but to incinerate exposed infantry inside open vehicles. The physics of thermobaric detonation in a confined space is one of the most brutal phenomena in modern warfare. The initial explosion disperses a cloud of fuel aerosol in all directions, and a fraction of a second later, a second ignition converts that cloud into a pressure wave that has nowhere to escape. In an enclosed vehicle, the overpressure multiplies. It is not an explosion, it is a compression event. The 6-cell lithium polymer battery read 25.2 volts. Full charge, enough for 6 minutes of operation. The target was 3 minutes away, a light blinking in the darkness waiting for them. The math was simple, the execution was not. The frame weighed 1.4 kilograms without the warhead. With it, 3.6 kilograms total. This was not a nimble racing drone. At full throttle, it reached 110 kilometers per hour, but its maneuverability in crosswind conditions was compromised. Every meter of altitude gained fighting the storm was a meter of battery consumed. In the operations center, the pilot ran the flight plan in his head 3 times. Last known position of the flare plus the convoy's forward speed minus crosswind drift at 30 meters altitude. He had one real shot. The Russians would hear the motors. They had anti-drone personnel on every vehicle, and the MTLB's electronic system was still broadcasting. The first 2 kilometers were clean. The FPV drone screamed low over the frozen forest at 3 meters of altitude, using the tree line as natural shielding against both radar and direct visual detection. The video feed inside the pilot's goggles was sharp and clear. For about 90 seconds, it looked like it might actually work. Then the wall of interference hit. The image inside the goggles began to tear. Horizontal noise lines cut across the feed. The control inputs felt sluggish, as if the drone was responding through water. Battery voltage readings dropped erratically. The MTLB's system was not physically damaging the drone. It was doing something subtler and more dangerous. It was introducing latency into the control loop. Fractions of a second of delay between input and response. At 110 km per hour, fractions of a second are the difference between impact and miss. The Russians had learned this lesson over 3,000 destroyed armored vehicles. You do not need to shoot the drone down. You only need to cut the invisible thread connecting it to the human being holding the controller. This is where the Ukrainian engineering team's most controversial modification became critical. Sewn into the drone's frame was a machine vision AI chip. Chip hardware, no larger than a stamp, trained on thousands of hours of Telegram combat footage. Its single function: identify a Russian vehicle profile and maintain a targeting lock during the final approach phase, independent of the pilot's input. An autonomous terminal guidance system built from off-the-shelf components for under $200. But the chip had one absolute requirement. It needed 2 uninterrupted seconds of clear visual on the target to initialize the lock. The drone still had to fly another 1,000 meters through electronic interference before it could see anything. The pilot sweated through the calculation. No video, no GPS, only dead reckoning. Last known position plus speed minus wind. He pushed the throttle to maximum. If you are going to crash, do it fast. And then, for 1 single second, the interference stopped. Perhaps the MTLB hit a pothole. Perhaps the system cycled between frequency bands. It did not matter. In that fragment of signal, the pilot saw everything. The magnesium flare still burning white on the icy road, and crossing through the smoke, the unmistakable silhouette of the lead buggy. The static crashed back immediately, but the AI chip had its 2 seconds. The targeting reticle locked green. The pilot knew the drone was going to hit something. What he also saw in that 1 second window was everything behind the lead vehicle. 10 more quad bikes fanning out in a dispersal pattern, moving fast and too spread out to stop them all. There was no time for a second drone. There was no second drone ready. This single platform, with its burning battery and its damaged motor signal, was the only answer available. At 9:16 AM, the FPV drone entered the engagement zone. The Russian soldiers on top of the MTLB reacted first. They had trained for this. They knew what the sound of a racing drone motor at full throttle meant. The rifleman raised his AK-12 and opened fire at 40 meters. At that range, the bullets arrive before you hear them. 1.545 millimeter round connected. It severed the front right carbon fiber motor arm, leaving the motor hanging by its power cables. The flight controller, a computer the size of a coin executing 8,000 stabilization corrections per second, entered what engineers call a failure cascade. 3 motors fighting against gravity and sudden asymmetry. The drone lurched hard left, bleeding altitude, angling toward the snow. At 25 meters, the dedicated anti-drone gunner on the second vehicle opened up with a Saiga 1-2 automatic shotgun, loaded with birdshot shells. A cloud of 200 pellets spread across the air. Most missed. 2 found the drone. 1 pellet punctured cell number 4 of the battery pack. Voltage on the pilot's display collapsed from 19 volts to 11 inches under a second. The thermobaric warhead remained armed, but the drone was now operating on borrowed time measured in milliseconds. The AI chip fought to hold the green lock rectangle over the MTLB's rear access door, but the distorted input from the shattered camera lens and the asymmetric thrust was corrupting the tracking algorithm. The rectangle flickered. At 10 meters, a third Russian soldier leaned out of the rear hatch to engage the drone. He had identified the exact approach angle. He was correct. And he had discovered the fatal design flaw of traveling in a Soviet battle bus. The rear doors are 4 millimeters of aluminum. The drone was flying at 50 centimeters of altitude, below his line of fire. He tried to angle downward, but his body armor caught on the door frame. Half a second of delay. The pilot spent the last electrons in the battery on a single directional input, straight through the open rear hatch. Impact at 9:16 AM and 12 seconds. The drone entered the troop compartment at 50 km per hour, slowed, battered, missing a motor, but carrying 2 kilograms of thermobaric compound that does not care about the condition of the vehicle delivering it. The cables touched, the circuit closed. The TBG-75 detonation occurs in two distinct phases, separated by roughly 4 milliseconds. The first charge blows the warhead casing and disperses the fuel mixture in a sphere approximately 3 meters in diameter. In open air, that sphere expands, and the second ignition produces a fireball of limited destructive radius. In a closed space, that sphere has nowhere to go. The fuel mixture saturates every cubic centimeter of the crew compartment in under 2 milliseconds. Then, the second ignition fires. The overpressure inside the MTLB's aluminum troop compartment multiplied by a factor of 300% above what the chassis was designed to contain. The vehicle was never a tank, it was a cargo box. An aluminum shell filled with ammunition for the buggies, fuel reserves, and now a detonation that had nowhere to dissipate. For a fraction of a second, the thermal imaging camera on the Ukrainian surveillance drone, which had just been powered back up 3 kilometers away, recorded something extraordinary. The 12-ton armored vehicle visibly expanded. The hull plates bowed outward like a tin can being squeezed by an invisible hand. And then the weld seams failed simultaneously. The MTLB opened like an explosive sardine tin. The roof panel of the vehicle launched skyward, spinning through a column of black oily smoke that climbed 200 meters into the February air. The electronic warfare system, the one that had cost so much to neutralize, was ejected sideways into the tree line, converted in an instant from a strategic-grade jamming platform into smoking wreckage. The black smoke column rising over the white fields of Petropavlivka was visible from 7 kilometers in every direction. The Russian column dissolved in seconds. Without the MTLB's electronic umbrella, the 11 quad bikes and the remaining buggies were suddenly naked. No jamming, no interference protection. The Ukrainian reconnaissance drone, back online, had a perfectly clear thermal view of every vehicle on the road. Coordinates were transmitted to the artillery battery in under 20 seconds. But the Russians did not wait for the shells. Panic did the work first. Faced with the burning wreckage of their lead vehicle blocking the narrow road, the convoy drivers attempted to reverse and turn simultaneously on a frozen track barely wide enough for one vehicle. Two buggies collided. A third slid off the road surface into the snow-covered shoulder, directly onto a concealed anti-tank mine. The secondary explosion sent fragments across a 40-meter radius. The assault force that had been 45 seconds from breaching the Ukrainian trench line scattered into the surrounding forest on foot, abandoning vehicles, abandoning equipment, in temperatures 10 degrees below zero, with no electronic support and Ukrainian artillery acquiring targets. Of the initial force that crossed the contact line, the after-action assessment accounted for fewer than 30% reaching any form of covert position. This is the true shape of modern war. Not the shape of armies, not the shape of doctrine, the shape of a cold basement, a burned-out battery, a $200 AI chip, and 1 second of clear signal in an ocean of noise. It does not matter how many tons of steel you weld onto a Soviet-era tractor. It does not matter how many millions you spend on electronic warfare systems designed to blind NATO aircraft. Somewhere in a frozen basement, there is always an engineering student with a $400 drone, a modified firmware, and the patience to wait for the exact moment you make a single mistake. 1 second of hesitation, one pothole in the wrong place, one door left open, that is all it takes.